Right, we're going to go through 1.3.2 database. It's going to cover these two parts of this unit. So let's go. So first of all, what is a database? Well, it's a place where you can store, search, and analyze data. Normally it's on one topic, but it could be on lots of things. Access is one of the most used database programs in the world. Every search you perform on a website is basically searching a database backend. So let's go through the different types. So you've got a flat file database versus a relational database. Now, in the GCSE, if we looked at anything, we'd have looked at flat file. So basically, all the data is stored in one table. I'll show you an example of a flat file one. Okay, there we go. I've got one table or entity, as they're sort of more known in the descriptive theory. And I've got all the data in one flat table. There's no relationship. There's no multiple tables. It's one table. And so normally, you've only got one entity, an entity being a category or event. So it could be a Pokemon if you're doing a Pokemon database. It could be a football team if you're doing a football team database, and so on. They're easy to make, but they're not usable in the real world. I mean, you can do for very, very, very simple, next to nothing databases, but, you know, not really. So a relational database is spread across multiple tables. This avoids repeating data, or at least limits it. But it can be difficult to manage, especially over time. So if I go back to my example of that flat file one, you can see that this is a booking database of something, cars, vans, whatever. And you can see that I keep writing in the cost of the car. I keep writing in Steve Smith over and over again, even though he's obviously a recurring customer. So this would be better served as a relational database. If I go to my relational one here, yeah, that's it. And you can see that I have made 3 tables now with customer, which has got the name in it. I put Steve and Mary in there. I've got the booking type with car and van in there. And I've got the bookings. I haven't added any bookings yet, but I'll do that live. So I set up the relationship between them. Now, I'll go through this in a bit more detail in a bit. But just what? So I set up the relationship between them. Don't worry too much. Why does it not let me do that? It's because it's open. Let's just close them all. There. Yeah, there we go. Booking type. There. Right. And I'll go through this one-to-many thing in a second and all this sort of stuff. But basically, the way to look at it is for one customer can have many bookings. Right? And one booking type, which is going to be like van, car, can be used in many bookings. So that's the way. I spelled booking wrong there, but don't worry about it. In fact, I will worry about it because I'm so fussy. There we go. Yep, save it. Anyway. So now if I go to table booking, I need to put a customer ID in. Now, if this was done in a nice form, I could search for a customer and I could do a form where I blah, 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 blah. But I'm just going to look at the customer. So I know that Steve is one. In fact, I could actually put the booking in here like this. But I won't. I'll put it in here. So I can put 1 for the customer. I'll put a date in. Not 34th, obviously. All that. And the booking type is 1, which I think is van. And let's do 1 for the other lady. And I think that's van. 1 is car, I think. Maybe not. Booking type. 1 is car, 1 is van. Yeah, there we go. So now if I go to the people, you can see they've got bookings under there. And I can actually add another booking in here. It's saying that there's no booking type 0. I need to put what type it is. So 2. I'll book a van this time. And so basically, I've set up a relational database where they're linked together. So this avoids repeating data because if, for example, I change my name, let's say I get married, whatever, Steve decides to be called Stephen. If I change Stephen there, it changes in all the bookings. Right? Now, it doesn't actually change here because it's linked by a number. But if I was to have a nice form up, I could do a form. Very quickly, I could create a form. That's not what I wanted. I did the stupid form. Create form wizard. I want all the booking and then I want the customer details as well. Yeah, no, I got them. There we go. So now you can see the customers there, and so on and so forth. Yeah, and if I change the name and actually save it, and then close it and reopen the stuff, yeah, hopefully it's changed to Stephen. There you go. See, so you can see that I don't have to retype his name in. Okay, I just put the customer ID in, and it changes to the customer that it is. Right, and I could do various searches. Right, so that's what a relational database is. It's about avoiding repetitive data entry, right, and linking it all together. Okay. So let's go back to the theory. Okay, so that's a relational database. So an entity, which is basic in a database, have attributes. I think of it like a class. You can think of an entity as a bit like a class. You've got a class called booking, and it's got the booking ID, customer ID, booking date, booking length, blah blah blah. And these are like the variables I like to think of the thing. What information am I storing about the data? Now you'll notice these ones are underlined. And that's because they're called the primary key. So every entry in the database, if we go here to customer and design it, the customer's open, doesn't matter. See, I've got my customer, I've closed it now, so that should be less grumpy. ID, and there's a key there saying that's the primary key. So in a database, every record, which is one thing, one actual thing, an entity being the design, a record would be the actual, a one of that thing. So this is an entity of customers, and this is a record be one customer. Needs an ID number, something unique about them that represents them in the database. Now that is called the primary key. It's like, what's its name in the database? It needs to be unique. Now I'm having the computer auto fill those in. It just goes 1, 2, 3, 4. I can type them in, or if the subject has something unique about them, like for example car reg. I mean, you could use that. I probably still wouldn't, but I don't know. You could use it. So like if there was something completely unique about that thing, maybe it had a serial code, like, and that serial code was completely unique, you could use a serial code. Like at work, for example, I have a staff code that's completely and utterly unique. That could be my primary key in the database. Only one member's got that code in the whole school. Mine is Cam2, and I am that person. I don't know if they would do that, because if I leave, would they have to never use Cam2 again because they'd be linked to me? I don't know. But you can understand that they can. But it needs to be unique. Okay, so for example, name is not unique. Two people can have the same name, so you can't use that. It is possible to use something called a composite key, which is where you use two or more things to make something unique. I've got to be honest, I've never actually used this really in an actual database that I've designed, but there we go. But it is possible to use a composite key. Obviously, this would be terrible because customer name and customer date of birth are not unique. It is possible. Two people have the same name and the same date of birth. Actually, something quite similar happened to me with the NHS, and I got my data deleted. It wasn't the same date of birth, but it's very similar, and the same name, of course. But this would not actually be a good one because it's possible. But if it was that two pieces of information about something made it completely unique, like, I don't know, an order and an order line, like a line in an order, and there's only one line 5 in order 752 because there's only one line 5, then that would be a good composite key for a specific line of an order, like a part of an order or something like that. That's the only thing I can think of. I don't particularly do a lot of database design when I worked. I did a few, but nothing of major. I didn't really find it too brilliant at university either. I didn't like it too much for coding, and that's my area. So I don't know how often composite keys are actually used, but there you go. So a secondary key, right? When you search a database, I'm gonna try and find my thing again. The primary key is indexed, right? So what that means is it's going to do something to it, put it in order so that it's much easier to search it. If I wanted to index another one, there you go, I can index that, and now that's considered a secondary key. Doesn't really matter, I'm not going to use this anyway. But that's going to be a secondary key. So it's not really an identifier, but it just says that it's indexed for faster searching. I don't know if that will come up in the exam, but it's always good to know. But that's what a secondary key is. It basically just says, can you please index this, sort of sort it basically, or have some sort of record of what it would look like if it was sorted by that, or some sort of sorting's gone on. Doesn't mean it's saved it that way, but it's got some sort of record of where files are in it and in what order. And then you can search quicker with it. So a secondary key just speeds up searching, really. It does by indexing the file. It's not really got anything to major to do with other stuff. So these are different types of relationships you can have in a database. You can have a one-to-one relationship between entities. So, for example, one car company, that's actually not true. I don't know why this makes one car model. No, they don't. They make loads of car models. Stupid picture. I'm going to delete this picture. I didn't actually make this picture. I just got off the web, but that's a terrible one. I'm actually going to draw a better one now. Let's think. So one, I can't think now. One football team has one manager. Let's presume they've only got one manager, right? And he's a manager of only one team. Do you see what I mean? He can only manage one team. I'm sure this isn't legally true, but let's just presume it is, right? So there's only one manager of a football team, and he can only manage one football team, right? I know that's not necessarily true, but that's an example of one, right? Let's just say that it is, right? Then you've got one to many. Let's do football team for all of them, actually. So one to many. One football team can have many players. But a player can only play for one football team. I know that's probably also not true. But let's just go into the realm of normal, proper professional footballers. They only play for one team, don't they? You don't play for like four. So one football team can have many players, but each player only plays for one football team. Right. Now, this is a situation. Now, let me try and think of a situation. Well, I'll do the situation that we're going to solve in a minute. Not football teams. I can't think of a football team. So we're going to do one where there's a course and there's a teacher. But in this course, it's at university. And I know you're at school maybe or whatever, but you might have this in your school. And in fact, I think most of my classes do actually this year. They're taught by more than one person. So it's quite possible they're taught by more than one person. At university, you might be taught by 10. So a course can have more than one teacher, and this is a many-to-many relationship, and this is not allowed because you just can't make it. Basically, you can't make a table that has an unknown amount of teachers, and then the teachers have an unknown amount of courses. You would need like some sort of array or something like that, but they don't really exist in databases because they're going to be like a table, and we'll talk about how you fix that in a second. But this is many-to-many, one-to-many, and one-to-one relationship. Okay, so. This is fine, not fine. So what do we do? And how do you start the relationships? Right, so let's go back to the solution that I was talking about before. It's not this one, so I'll close it and go to my last one. Okay, just close this because I don't want to confuse you. Right, so I have made these two things. I've got a staff and a course, right? And staff I just put in here. They've got name, address, and email, and the course has got course name and course description in it, and there's an ID number. Okay, so it's nothing interesting. So if we go to the relationships, which I can't seem to find now, database tools, stop being an idiot, and I delete this. If there's no way, you see, to do many to many, because if I put staff in here, I'd need staff 1, staff 2, staff 3, staff 4. And then the staff would need course ID 1, course ID 2, course ID. So you're doing, there's no way to have a many-to-many relationship. What do I drag from where to where? Okay. So what you do is you add in a link one like this. I'm going to delete these. I have to close these down to delete them. It's very fussy. The database are very fussy when you're open. So I've got a table in between. That solves this problem. So let's have a look. Like this. Okay. But basically what I need is to put a table in between. Have one staff has many of this and one course has many of this. So you can think of it as like an order. So what I do is I create what's called a link table. And I link them by foreign keys. So here I've got the staff ID and the course ID. And I've got a whole new record entity here. So I'm going to put the course ID from the primary key here to the foreign key here. These are the same data type, both numbers. I'm going to enforce restaurant. I'll talk about that in a minute, what I'm doing there. So now I've got a one course can have many of this link. And then I'm going to drag the staff ID in here. One member of staff can be part of loads of these. So now I've got no many-to-many because I've put a table in between. I've got a one-to-many and many-to-many. This is called your primary key because it's the primary key of the staff. This is called the foreign key because it's a link to that. So if I want to add a course now, I go to course code and I can go staff ID. Now I know that the staff ID for Martin is 1. Okay, I'm sure there's a course code called 1. Yeah, 1. Right, so Martin teaches that course now. Now let's also make Sue teach that course. So we go here. She is staff number 3. Oh, but yeah, I'll press 2. And the course is number 1. Right, I'm now going to make him do 2. I'm just going to stick a couple of, I didn't want to do that, by the way. I'm just going to delete this, added this thing for you. I'm just going to make staff number 2, who is Gary, teach course 2. I'm going to make number 1 teach course 2. And I'm going to make everyone teaches course 2. Screw it. Right, so now if we go back to the staff, so you see I've got a table here, a record here, with just which staff do which course, but I can have an unlimited number on this table. This can go on forever. So if I go to the staff now and expand them, you'll see that, right, okay, I teach course 1 and course 2. Right, okay, brilliant. Then if I go to Sue, she teaches just course 1. Gary teaches just course 2. And if we go back to our course list, you'll see that's correct. Yeah, because only one person teaches 2 courses. Oh no, actually number 3 does. What? Oh, there you go. I think it was just updating. There you go. So you see, she teaches 2 courses, but Gary only teaches the 1 course. Martin teaches 2 courses. And so that is how you solve the problem of a many-to-many relationship. You put a link table in between. It only needs that. Okay. Although if it was like a booking or something, you could have other things in here. But yeah, so hopefully that's explained that to you. It's quite a tricky topic, so I didn't expect you to get it through the video. So I'm hoping, obviously with the stuff in lessons as well, you will have gone through it. So just understand that you link them from a primary key. So here, this is a primary key. This is a foreign key. It's the link, okay? Because remember, these are going to be numbers. So in a booking, they'll just be the number 4, and that will represent all that information now, okay? Because that's what it's linked, okay? Referential integrity, by the way, essentially means that I cannot put something in this foreign key here, this custom that doesn't exist here, and I have to put one in. And if you saw before, I ticked these boxes called cascade update, cascade delete. And what that means is if I were to delete, if I have cascade delete on, if I were to delete a customer over here, then because we have referential integrity and therefore this ID will link to nothing, like if that's linked to customer 4 and then I delete customer 4, then cascade delete will delete all bookings as well. You can set up settings for that and what to do if that happens in your database. You wouldn't really delete it. You wouldn't really delete a customer. You would like do stuff with them, back them up, push them off sales. It's something you do. And cascade update means if I change like the name or anything here, it will update. Or if I change the customer ID, it will update all those customer IDs in every booking as well. But yeah, so referential integrity means it enforces the fact that there must be an actual record in here that the foreign key links to. Okay, so that's what that is. I hope you got all that. It's quite a chunky topic, and that's why I've broken it up into quite a few videos. So good luck.